Hi everyone, have you ever wondered if there's a faster and even smarter way to solve really difficult problems? The computers we use every day, like laptops, phones, and gaming consoles, store information in something called bits. A bit can only be one or two values, 0 or 1, like binary. Quantum computers use something different called qubits. A qubit follows the rules of quantum physics, which is the science of very tiny particles like atoms or electrons. Unlike regular bits, a qubit can exist in a special state called superposition, which means it can be both 0 and 1 until actually proven. An easy way to imagine this is like a coin. A regular bit is a coin lying on a table, either showing heads or tails. But a qubit is like a coin spinning in the air. While it's spinning, it isn't just heads or tails, and it has the possibility to be either one. This unique property gives quantum computers a completely different way of processing information. To understand why computers are exciting, let's look at three different ideas. The first is superposition. As we just learned, a qubit can exist in multiple possible states before it's measured. This allows quantum computers to explore many possibilities at the same time. One, one example of a real scientist is called Schrodinger's cat. Essentially, the idea is that if you put a cat in a box, it'll be both alive and dead at the same time before you can actually prove it by opening up the box. And the second is entanglement. Entanglement happens when two can become connected in a special quantum way. When this happens, the behavior of one qubit is related to the behavior of another, even when they're separated. This connection helps quantum computers process information in ways that classical computers cannot. And the third idea is interference. Think about waves in water. Sometimes waves become bigger when they meet, and sometimes they cancel each other out. Quantum computers use a similar idea. Quantum algorithms are designed so that useful answers become stronger while incorrect answers become even weaker. And a simple way to remember this is that superposition creates possibilities, entanglement connects possibilities, and interference helps to find useful answers. So why does it matter actually? Why do we even try to study quantum computing or whatever? So why are scientists and engineers so interested in quantum computing? Quantum computers aren't really meant to replace everyday computers, but instead they're supposed to be developed to solve certain types of problems that are extremely difficult even for the most powerful classic computers. One area is medicine and chemistry. Since molecules follow naturally quantum rules, quantum computers may help scientists even better understand diseases and discover new materials. Another area is optimization. Imagine trying to find the best delivery route, airline schedule, or traffic pattern among millions of possibilities. Quantum computers may eventually help solve those problems even more efficiently. In quantum computing, it also influences the future of cybersecurity and communications, which is why researchers are already developing quantum safe security methods. So let's end with one important message. Quantum computing isn't just about replacing today's computers. It's about giving us a new toolbox for solving tomorrow's hardest problems. Thank you for watching. If you enjoyed this video, don't forget to like, share, and subscribe.